I would like to introduce you to Kai, from TIPCO. He's going to talk about the death of the enterprise service bus. Nice. Yeah, all right. Enjoy. Fantastic.
Okay, that's good, because I have a cold, so I'm loud too. Okay, great. Yeah, and that's what I want to talk to you about, how we implement microservices with our customers. And of course, afterwards, I'm ready for discussions. I think because it's recorded, I think I should do the talk at once, and we do all the questions afterwards. And so let's get started. First, the key messages. What's my point of view about what you should take away from today? Lots of problems. So the first one is already one where many people do not agree. So what I say here, microservices is so done right, and I will also explain on several slides later why that we think it that way, and afterwards we can discuss. The second message is what we see is that integration definitely is the key for success when we build microservices, and we don't care if you call it ESB or something else. I will also talk about the branding and the terms and the products and so on, and all these discussions. And yes, it's smart endpoints and dumb pipes, what everybody knows about microservices, and that's absolutely fine, and no argument against using products like ESB or whatever you call it. And the third one, I will also talk about that with use cases from customers we see. What's really the benefit our customers get is when they correlate all these different microservices, when they combine these events to get added value out of that. And that, in our opinion, is really a game changer for the customers, where they really add the value after they've implemented the microservices, and then how they correlate them. That's really things like log management, like event processing. And I will talk here about several different tools, so it's not a typical pitch. I will also talk about open source tools. And also in the live demo, which I will show later, I will use open source products like Cloud Foundry as platform as a service, or software as a service, which is not TechCo. So you will see a lot of different things here. And for the agenda, first a very short motivation about why we are talking with our customers about microservices. And really they are coming to us, so it's really the other way around. They are asking us, Kai, how can we implement microservices with TechCo? And then, nevertheless, I will first talk a little bit about our point of view about an enterprise service bus. Because especially from a microservice perspective, many people are not happy with an enterprise service bus, and I will discuss here from our perspective, because as many others, enterprise service bus, that's just a definition, it's not a standard like JMS or HTTP, so it can be many different definitions. And then I will shortly define microservice, how we understand it in this relation. And I think the key really of this talk today is how we define the architecture and these requirements when we work together with our customers to make them leverage microservices. I will show a short live demo using, of course, some TIPCO products, but also others like Cloud Foundry and others. You will see that in the live demo, how we develop and deploy microservices to the cloud, how we scale it, also how we monitor it and that stuff. And at the end, I will talk a little bit about the challenges we see at our customers. So first, motivation. The key really is the digital business, which we see everywhere. And that's really not just by the analysts, but all the enterprises have to implement this these days. So I just want to give you one example of a customer. It's the Sacramento Kings, which is a basketball team in the US. And they are building a new stadium right now. 20 or 30,000 seats, and what they are doing, they are really connecting everything. So every seat has an iBeacon, for example, so that you can analyze all the information. But it, let's fix this one time. Okay, that should be better. So Sacramento Kings, what are they doing? And they are really integrating everything, but the important thing is it's not just about their team and their company and their software, but they are also working together with a lot of partners like restaurants and sponsors and all of that. So it really begins when a fan drives to the stadium. So when he takes a look at his mobile phone in the car, then he already gets informed that he should park, because where his seat is, so he should park on that parking lot or something like this. And then when he's going to the stadium, he gets, for example, a push message because he can buy an upgrade for a better seat because it's available. and after the game, when you leave the game, you get a push message, for example, because a restaurant has a lot of free seats, and all of that is happening in real time by correlating all the information about the different customers and their what they are interested in. And that's in the end only possible by the way which we present, or I present the architecture today, with microservices where you're really flexible to do all that. And that, I think, is really the key, because this was just one use case, and we have many, many others in every different brand and vertical. So it is banks, it telcos, retailer, whatever you think about. And we see all these requirements everywhere. And the key here really is, so we are not saying, guys, you have to implement everything with TIBCO. So I mean, that's also what some people still think. I mean, that might be true 15 years ago, that someone from IBM says, guys, use just IBM and TIBCO, only TIBCO. Right now, that's not possible anymore. So you have to use standards, and you can use frameworks for that and a product for that, and combine all of these things. The key really is that you have to be flexible and integrate all the different channels and contexts of your partners, like restaurants in this example before. And they will also not use TIBCO, but you have to work with them together. So it's absolutely fine. The key really is to be flexible. And so also what we heard in May 8th, and that's a good site, I think, for beginning for intimate motivation. Here the guy said, applications created today using the good old traditional architecture will be a business constraining legacy before they are completed. And that's in the end really true, and I have seen that again last week at a big customer. They have started a project. It was a $20 million project, and now we got informed that they want to replace it, and are asking us if we can help them. And it's not even completed, and they're already replacing it. And we have seen that so many times in the last 10 years with SOA projects, because it was a lot of complexity, but there were a lot of problems also. And therefore, I think is why the customers are also now talking about this microservice idea, to be more flexible. Nevertheless, let's talk first about the ESB, the Enterprise Service Bus. As I said, many people do not like the term or the product behind that. I'm absolutely fine with that, but one thing before I begin is really, I have done this talk 2 or 3 times last year in Germany, and many people said to me, I have used an ESB 10 years ago and it was horrible, it did not work, it did not scale, the tool was bad and so on. So here I would really have to say this changed. So today these tools work, they scale and they are easy to use. And it's not, does not matter if it's TIBCO or an open source like MuleSoft or Talent or any of these, though they are also working, though it's not like 10 years ago. That's only very important to understand. If you really do not like ESBs, then take a look at a modern ESB, and then it's absolutely fine if you do not like it. But nevertheless, what we see at our customers is really that they have a lot of different applications. It's legacy applications, it's custom Java applications. New things are coming like Internet of Things, like Hadoop clusters. Now everybody wants to use Spark and so on. You still have the mainframe and host which you have to integrate. You have the SAP system, ERP, you have cloud services like Salesforce. They all have to work together. And especially the big customers which TIBCO has, or IBM or Oracle. Like, for example, my customers in Germany are Lufthansa, Deutsche Bahn, Deutsche Bank, Deutsche Telekom, so really the big ones. And they have so many different applications which they have to combine somehow to get value out of that. For example, the Deutsche Bahn, the German railway, they have 20 different systems which are just used for defining railways with all different concepts and so on, and it all has to work together somehow nevertheless. So it's really complexity which you have to solve. And if you now take a look at branding, so because that's when someone talks about an ESB, what do you mean with that? I mean, here, as you see in the past, you talked about application integration, then now about service integration, in the future maybe about integration of everything, because there's the Internet of Things and whatever will come in the future, nobody knows. In the past we had the broker, then we today have the ESB, the bus. In the future, or already now, many people are talking about a gateway. And the same for the applications, which in the service-oriented architecture we had the services, and today we're talking about microservices and also about APIs. So in the end, I don't see much difference between an API and a service, but again, that depends on how you define it. And So to give you one example about this branding, because that's really important. If you talk about ESB, you have to think about what do you mean with the term ESB. So for example, at TIBCO, we're doing integration and event processing for 20 plus years. And if you take a look at the past, let's say in the year 2000, there everybody talked about enterprise application integration, EAI. That was the term every vendor used, IBM, Software AG, Oracle, all of them. 2005, that changed. Everybody had to use a service-oriented architecture, and sometimes it was also called an event-driven architecture. So the terms changed a little bit, sometimes the tools changed a little bit, but in the end, it was all about integration, about messaging under the hood, using different standards, and integrating all the different applications. 2010, yeah, there was still service-oriented architecture with an ESB, but there were a lot of other things like business activity monitoring or other things like complex event processing came on top of that. So the branding changed a little bit, the features under the hood still the same. And if you take a look today, or last year 2015, now the vendors are talking about API management. So you have still the services and you expose them, and now it's called API, or sometimes we call it microservices, which we expose via API, or whatever you want to call it. The same story like for TIBCO, of course, for the others too. So if you take it there and look at their old websites, it's the same. And also, by the way, TIBCO BusinessWorks, that's the integration platform for TIBCO for now 20 years or so. It was never branded ESB, but nevertheless, everybody thinks about it as an ESB. So, that's really about the branding a little bit. And in the end, if you take a look at Wikipedia, what is an ESB? And ESB is a software architecture model. And under the hood, it is used for integrating the different systems somehow with some standards, or also with the old term enterprise application integration. What now many people think about it as an ESB is really the central integration platform. And I will come back to that later when we see the microservice definition, which is a current standard, I would say, with REST service and so on. There, they criticize exactly that of an ESB, that nobody should use an ESB because it's the central thing in the middle and it's complex with people and all these processes. And that's the view of some people about an ESB still, but that changed a lot, and since many, many years, many ESBs, and again, not just TIBCO, but also if you take a look at Talent ESBs or open source ones or JBoss, in the meantime, they are no central broker anymore. So they are distributed messaging middleware backbones where you can integrate the different software and scale it easily. And you do not deploy everything as complex application. You really implement integration services and deploy them by themselves and scale each service by itself. So that is what TIBCO customers are doing for 5 to 10 years. They implement not big projects, but small integration services, and they deploy each of them by one. So they scale one service how much they need it. And so in the end, when you later take a look at the definition of microservices, that's also what everybody is requesting. So it's really a key that you think about how do you define the ESB. And then there's also the hashtag NoESB, where several people now are talking about is the ESB dead. And this one is a really good one. I can really recommend. I have added a link. It's from Gartner, so the most important analyst of the world probably. And they have a really good content here to explain why do customers use an ESB, what is it used for. And I will talk about that in a minute, but in the end it's the integration platform and nothing else. So if you want to summarize it in one sentence. On the other side, there are other vendors. So for example, if you take a look at Arcana former SOA software, they are offering an API management solution. And they say that an ESB is dead and too complex and so on. And then if you take a look at their tool, they have an API management solution, but their tooling is doing exactly the same like the ESB of all the other vendors. It does graphical mapping, it has connectors to different systems, and does the orchestration and so on. So it doesn't matter how you define it, ESB, API management. In the end, it's about a few things. And so that's really now, after a lot of slides, my definition for today for the term ESB. what we see and our customers see. So the branding does not matter. So as I said, typical BusinessWorks isn't even branded on ESB. What we care about in our customers is really that you use a flexible, distributed, and a scalable infrastructure, so that you can really deploy any service by itself and scale it by itself using continuous integration and all these things we use today. No matter if you use just coding and frameworks, open source frameworks, it's absolutely fine. But even if you use an ESB, and in this term here, what we understand an ESB, it's absolutely the same from a development and operations perspective. So what do you use an ESB for? For integration, definitely, that's the absolute key. For things like orchestration or routing or correlation, that's the things you can use an ESB for easily, because it provides the tooling to implement that easily. It's about many different technologies. When we talk about microservices, many people just talk about REST, and I come to that later again, but I think you cannot solve every problem with REST services. It's a synchronous service call in the end, and there are other things like messaging with WebSockets or other standards like MQTT, which are built for Internet of Things and other new modern styles. And therefore, in the end, it's not just about REST, usually, at least in our experience, at the big customers with the complex scenarios. And the key, I think, here really is from when customers use our ESB, they really deploy these services independently from each other with a standardized interface, like REST, HTTP, like SOAP, like JMS, or whatever they want to use, and they build it with continuous integration, and all these things you probably also use with frameworks. So that's really in the end what we understand an ESB, and I think that's very important. When I do a talk about is the ESB dev or how it is used with microservices, that's really our definition of an ESB. I think that's really important. And now we are at a microservice meetup, so I think I do not have to define it a lot. And even for microservices, it's the same. If you ask 5 people, they have 5 different opinions about what exactly is a microservice. So in my understanding, you really use a microservice to implement a limited set of functions. And much more important also is that you develop, deploy, and scale every service independently. That's the key, and therefore then you can be flexible, because you can change one service without changing all the others, and also the same for all the complete development lifecycle. And then you then have the benefits like shorter time to results and the increased flexibility. I think that's really the key of microservices. And the funny thing now is, well, we told our customers the same 10 years ago with SUA. So the basic idea behind SUA, if you take a look at, for example, Thomas Earle's books, they are very famous SUA books, 1,000 pages, but they define exactly these ideas. And what I see at our customers, and so if you wonder really, it sounds like SUA, is it SUA? Then, well, I think from the basic idea, maybe it is the same, or very similar, but the service-oriented architectures we see at our customers are much different than they should be, and that's the key problem. One reason is that the tools and open source frameworks were not ready for that 10 years ago. There was no continuous integration and Docker containers and whatever you can use today for being flexible and ease of use and so on. So what do we see now today, what our customers want to implement with microservices? And what they also wanted to do 10 years ago with SOA, but they did not, because for several reasons, complexity of tools, or organizational problems, and so on. So, and that's really what we see now, what our customers implement under the term microservices. So they do not commit for any unique technology. So they do not build everything with TIBCO or with IBM or so. They choose the right tools for the right job, and that's absolutely a good thing. And we have no problem with that, it's absolutely fine. And the key is really the greater flexibility of the architecture, that you can build and deploy and scale every service by itself. Now that's really a huge benefit. And yeah, in the end, each service has its own life cycle as managed as product. And also the key, as I said, the industrialized deployment, continuous integration. Some already use DevOps or these things. That was not available 10 years ago because the frameworks were not there. And also a very important point, when you talk about microservice today, everybody says dumb routes and smart endpoints instead of a heavyweight ESB. That's in the end absolutely fine. So the key here is nevertheless that you still have to integrate the different systems. As I said, usually you do not start from the greenfield with everybody building new, but you start with many existing applications, legacy systems, and very complex monoliths and all of that. At least at the big customers, at the customers we work for or work with. And so that's in the end now, I think, really the keys of how we implement microservices with our customers. And to be honest, many of them also still call it SOA because it's a defined term for them and it's a strategy and it's absolutely fine. The important thing is how you realize the concepts under the hood. So I never start a discussion about is it SOA, is it ESB, is it microservice. The real thing is that you get the benefits and the flexibility out of it. Yeah, and as I said now, the key point I think of this talk is the architecture. How do we realize that with our customers? And in the end, most of that I will also show at least shortly in a live demo. Does the service contracts are important, of course. And what's also important for microservices, you do not just build new REST services, you also have to expose old services as flexible microservice. The other problem is now you have a lot of microservices, you have to discover them somehow and manage them and make them available to others for usage. You have a lot of services, so you also have to coordinate across different microservices or services. You have to manage the complex deployments, and what's also key in the end, what many do not think about in the beginning, is the correlation across services. And so let's take a little bit deeper look at all of these. Service contract, I think that's really clear. I mean, that was always available in different technologies or whatever it was. But here it's really you have a service provider and a service consumer, and they have to communicate somehow with each other. So I think a service contract, whatever it is necessary. And if it's just a REST HTTP interface in the end, that's also absolutely fine. But you somehow, I think, have to know how you can communicate with each other. And what do we see in practice today? I would say mostly we are still seeing SOAP web services our customers because it's many years old and sophisticated in the meantime. In the meantime, it really works very well. That was a problem a long time with all the WS star standards. But in the meantime, it works very well. And I think it's still a good standard for some purposes. So for internal communication, you have also a lot of benefits of SOAP. Even though I do not want to start now the discussion SOAP versus REST and so on, but I think it also has its benefits. Nevertheless, of course, in the meantime, you talk a lot about REST when you build microservices. Nevertheless, also what we see, and not just at our customers, but also when I read blog posts and so on, it's not the real REST, which is defined in this degree dissertation with hate OAuth and this stuff, so and hypermedia. So I've never seen that at a customer really. In the end, customers define REST services with operations which they implement for GET, for POST, and so on. From our perspective, that's absolutely fine because it works right now, and it works with good tooling in the end. But also, what I think is very important, and I said that before, in my opinion, messaging is getting more and more important because of things like Internet of Things, sensors, predictive analytics, where you have to process millions of messages. So, for example, TIBCO has a tool which is called TIBCO FTL. FTL stands for faster than light. That was the engineer who built it, made that name. But with that tool or messaging framework, you can process 7 million messages per second. So just that you get a feeling about how this changed, and this is not really a good thing to implement with RESTful HTTP synchronous calls. So I think today for microservices usually you use REST, especially if you do not just use it internally but also to the external world. But I think we will see messaging much more in the future, also for microservices. We will see what standards will be mostly used, will it be WebSockets or MQTT or others. But I think we will see a lot of more messaging, even in the microservices discussion. That again, I especially talk about our customers where I see that. Because others of you might have other experiences. And of course, we can also discuss this after the talk. So after service contracts, what I also said, you have not just to build new services, but also expose existing applications as service or as microservice. So of course, the best case is that you already have a service-oriented architecture. You're already using services, and you maybe build some other services which integrate and coordinate the services. But also, what again, many of our big customers with a lot of legacy systems have to do, they build services on top of their monolith application. So even technologies like the IBM mainframe are supporting web services in the meantime, so that you can expose parts of it as service to the outside world. On this slide again, you see sometimes I'm not so clear about when do you use SOA or service or microservice or API. In the end, it doesn't matter what the term is for that, in my opinion. And what's also relevant here, what we see is other services like software as a service. Almost all of our customers in the meantime use some kind of software as a service in their enterprise, like Salesforce for CRM. I think at least every second of our customers use a Salesforce for CRM, and you do not have any control about these services. But nevertheless, they have to communicate together with the other ones, so you again have to integrate them somehow. And I think what's important here, again, I mentioned that also in the beginning, is this topic about smart endpoints and dumb pipes. It's defined by Martin Fowler and these guys. And the only problem I here have again with, because here you read about, and this is cited from the Martin Fowler blog, and here you read about the ESB, which often uses sophisticated facilities for message routing, choreography, and so on. And what I don't like here, if you read the red one, these are choreographed using simple REST protocols rather than complex protocols such as WS choreography or BEPL or orchestration by a central tool. And that's why I explained for a long time in the beginning the term ESB and what we understand, or what our ESB is at least, because that's simply not true with all these definitions that an ESB is a central broker and it uses BEPL and WS choreography and so on. So in the live demo later I will show you how we build microservices, for example, with REST services. And then in the end you compare TIBCO REST services with REST service built with a Java framework, and you can also combine them, that's absolutely fine. But you use, or our customers use our tool to build exactly these microservices which are defined here by Martin Fowler. They're just using a tool which generates the code, but the basic concepts and the code are exactly the same. You just use another tool or product or framework for that. So in the end, yeah, that's just a summary of what I said. ESB defined, as defined in this talk, has nothing to do with WS star, BEPL, or all these things in a central broker. So I will show you a little bit in the live demo, but really the difference in the end is that our customers often, and the same is true probably for the other vendors, is that they take a look at, for example, the total cost of ownership. How long does it take to build and maintain the services? What about guarantees, about scalability, about 24/7 support and so on? And then they have to evaluate. Sometimes you use just an open source framework and build your own application. And on the other side, sometimes you use a product like from TIBCO or IBM to build your microservices. Because it's a trade-off, and you have to think about what's the better one. And here with the products, like with TIBCO or IBM, use the graphical tooling for building the service, and the code is generated and delivered. And as I said, even if you're building microservices, you still have to integrate a lot of different technologies and products. So I don't see a customer which can integrate anything with REST because he has mainframes, he has big SAP implementations, and many others. And here again, you can code everything, absolutely. Or you can use such a tool where you have all the connectors out of the box. So it's always a trade-off. You have to think about what's the right one for you. I will show you that in a minute in the live demo. So the third point is discovery of services. And I think that's also very important if you talk about microservices, that here the world is changing, and in the meantime, also at most enterprises, I would say, to the open API economy. And the funny thing is here is nobody's talking about service or microservice here. All the vendors and frameworks are talking about APIs and open API. Again, is it a service, is it an API, it doesn't matter. But the key difference is that in the past, how did you communicate with partners and with external applications? You used legacy things like EDI, EDIFACT, which is absolutely complex to integrate and communicate with. Or other B2B solutions, or FTP file server. Almost all of our customers still are using file transfer and batch processing instead of real-time processing. They know that they want to prefer real-time processing, but it's not so easy because it's a lot of effort, of course, but they're all going that way to use APIs. So for example, 2 weeks ago I was at Miles & More, which is a loyalty program for Lufthansa, and they have exactly this issue. And if you are in one of these loyalty programs, and in the end, for me it's Lufthansa, it's Hilton hotels, and if you wonder why do you get your new points after 2 days, after 3 days, or if you fly with United or Delta, then you get it after 1 or 2 weeks. It's because all these systems are still integrated with the legacy, with the old things, and this is changing these days. So our customers here are changing to this way, to use open APIs instead of the complex integration with batch processing and complex data formats and so on. Open API, I think it's really a key important also for microservices. And 3 examples here for Open API. I mean, probably everybody knows PayPal. PayPal was first just used for eBay, for paying transactions. In the meantime, almost every shop you buy something, you can pay with PayPal. And the business model behind this is that they get 3% of every transaction. And there they earn billions of dollars every year. The second one, Amazon, probably also many of you know, that Amazon is implementing everything with an API, everything as a service or microservice, whatever you call it. And everybody can use these services to get Amazon instances with Linux or Windows, or just storage or a Hadoop cluster or so. It's all available as API, and they get money for every hour you use it. And then you see the next benefit of that. And that is similar to the one I had in the beginning with the Sacramento Kings and the stadium, where everything is connected. So everyone has these services and APIs, and you have to combine them to get the value out of it. In the Sacramento Kings example, they work together with the restaurants, with the sponsors, and so on. And here you see Domino's Pizza was the first one which had a mobile enablement where they integrated the different APIs. So they offered their API to the outside world, so that, for example, a hotel can integrate this API in the hotel website, but under the hood, by themselves, they are integrating the PayPal API. So here you see how these different APIs, or services, or microservices are combined with each other. And that is where you really get the most benefit then out of it. I also have 1 or 2 examples about PayPal again here. So PayPal has built their own solution for API management. They built their own microservices, and then they have the API gateway on top of it to publish this to other ones, like you see here, to Wallet or to eBay or to Uber, to online websites. That's in the end really one part. If you implement all these different microservices, you have to make them available to others that they can use it. And therefore you use what the vendors and the analysts today call API management. API management is available from different vendors and also open source frameworks from JBoss and so on. So again, or you can build your own, of course. Nevertheless, the key really is here, first you create your APIs, in this screenshot again with a tool like BusinessWorks, or you write your Java code for the service or a microservice, and then you build a product out of it. Usually, most of our customers use a portal where everybody can register to the portal and try out the services and test them and read the documentation and subscribe in different plans. And finally then, these APIs are distributed, so depending on the customer of course, but for many of our customers worldwide. So that the customer really just cares about the implementation of the business or integration logic, and then he deploys it and makes it available to the public, and he doesn't care about scalability and about distribution over the world. So that's what the toolings are doing for them. Here again, if you see the examples of Netflix and PayPal and so on, they are building all of that by their own. But most other companies, which are not the IT giants, they are using either open source frameworks or products for that. Yeah, and these two together in the end are what most see as API management. And so if you take a look at these frameworks and tools for API management, then the key, I think, from the end user perspective is the API portal, and under the hood you have the API gateway, where you define things like security, authentication, authorization, but also other things like throttling, for example. That if you buy a product and pay only $5 a month, that you can only do 1,000 service calls. And if you want to use more service calls, you have to pay more. And these things like throttling or caching and all that stuff, that's implemented in the gateway. And usually the third part of it is API analytics, so that both the service provider and the service consumer can see how it is working with the services or microservices which you use. The fourth part of the architecture which we implemented customers is then when you have a lot of different microservices, they have to work together because otherwise it doesn't make much sense usually, so you have to coordinate them. And here again we have the topic smart service, dumb pipe, no fat heavyweight ESP in the middle, so that's absolutely fine, but nevertheless you have to coordinate them somehow, and if you use a tool like an ESP, then you do that graphically and build your new REST service, for example, which coordinates other REST services. That's one of the possibilities you have to do that. The fifth one, I think that one is already clear because so many people are talking about it, managing complex deployments and their scalability. That's in the end what we're talking about, continuous integration, continuous delivery, with build tools like Ant and Maven and Gradle, and then combined with Jenkins or anything like this where you do it automatically. I mean, in the most projects I see today at customers, and again, not just with Java coding or source code, but also with the tools of the vendors. TIBCO, IBM, Oracle, usually they combine it with continuous integration frameworks. And here again, we see that a lot, that they combine it with open source tools. So that's maybe another point to make. The proprietary vendors, I want to say, they changed a lot. So I started for TIBCO 2 years ago, and if you talk to other people who worked there for 10 years, then that was really a proprietary company. There were no open APIs, you could not extend anything, you could not build your own plugins or connectors. You either bought it or you choose another vendor or something like this. And in the meantime, this changed a lot, so you can on the one side build your own connectors and plugins and extend the tool, but it's also out-of-the-box support for a lot of the different frameworks. So for example, what I will show you later, how we deploy services with business works. Right now it supports, for example, a Cloud Foundry as platform as a service, and later this year we will support Docker, and then you can deploy it everywhere using Kubernetes or any of these other frameworks which you want to use. And here really, and that's the same for others like IBM, for example. So if you read articles about IBM, what they are implementing right now, they're doing a lot with open source and add their tooling on top, of course, to sell something and to add value, but they are working together with open source today and not against it. And that's really also one of these things when you discuss about vendors and ESP and the thing, and with microservices, you can combine all of that very well in the meantime. Or sometimes it already uses it. So for example, when I show you the demo in a minute, we for example in the meantime use Swagger for the definition of our REST service and for testing and for documentation. So we integrated different open source tools. Our log management and monitoring solution is based on Apache Kafka and Elasticsearch. So the vendors are using the open source, of course, also because it leverages it. One more example here by Netflix again. The great thing about Netflix is that you can read a lot of good articles about these topics, microservices, continuous delivery, and so on. And they describe the same thing here, that you have to innovate continuously and you have to be fast and flexible. Like in the use cases with the Sacramento Kingston Stadium, you have to add new partners or change some APIs and so on, and that's only possible if you do things like microservices in combination with continuous integration and delivery. The last point, visibility and correlation across services, and this is what I see is the most interesting one, because it really adds the most value to the microservices architecture. And in the end, we see two different things here which our customers do. The first one is that as you have a lot of different microservices with different technologies and all that stuff, you have to monitor that somehow, and it's all distributed and different technologies and unstructured stuff. And so what many customers do in the meantime, they implement some kind of what was called in the past log management. In the meantime, the analysts talk about IT operations analytics, but again, no matter what's the term, the interesting thing is that you really monitor all the distributed microservices and information with one framework or tool. Otherwise it doesn't make sense, because if you have 100 microservices with different technologies, you have to get the information out of it if there's a problem, or if you can add some value somewhere or something like this. So if you take a look at different frameworks and so on, alternatives for log management, the open source ones, for example, Elasticsearch, log-Kibana is a stack many open source people are using, or Greylog is another one. In my demo later, I will use Papertrail, which is one of the software as a service solutions. It's very lightweight, and its goal is really to analyze many different distributed logs, to monitor all of them, and to automatically send out alerts if something is happening with these distributed microservices. And then there are also the let's say enterprise vendors, like Splunk is especially focused on that, or other big vendors like Tipcore, IBM also have their solutions for that. And the key difference here is that usually the lightweight software as a service vendors, there you can do basic monitoring of the distributed logs, and with the enterprise solutions you have first, again, much better tooling support for it, and you can do much more complex correlations and find out more, let's say, interesting things. But in the end, it's many different options you have, depending on, do you want to code, use open source, or use a product, or just a solution from the cloud. And the second part, and that's, I have a use case for that in a minute, is event correlation, or event processing, or stream processing, or streaming analytics. Again, many different terms you can use for that. In the end, what's the goal? The goal is that you correlate the information while it is happening. So in the past, if you developed some kind of web service, you did a change, you write something to a database, and sometimes later you analyze it. And sometimes later you find out something happened. For example, if you find out a fraud happened yesterday, then it's too late, because it already happened. If a customer already left the store, then you cannot cross-sell anything. If a machine already exploded or is defect, it's too late to replace it, because then it costs a lot of money. And so this is really what is the most added value when you have all these microservices and events. And here I explicitly say events again, because here often it's not just about synchronous REST calls, but it's messaging, it's sensors which are sending a lot of information. And you have to correlate that while it's happening. So to make that a little bit more clear, let's take a look at one use case. It's about predictive sensor analytics. So that's one of the key topics we see in many customers in different industries. And here it's about an oil platform, and at this oil platform they have many different sensors. So we will not go into any more detail, but this oil platform has many different sensors, and all these sensors send information, some every second, some every minute, but it's a lot of messages every hour, or every minute, even every minute or second. And what's happening now? There are different microservices which are implemented, which are sending different information. There's information about vibration, about temperature, and about voltage. A lot of different events sent by different microservices. And the event correlation And that's really the key. It correlates the different information of the different microservices to get some information out of it. So in this case, the rule is defined like this. If vibration spike is followed by a temp spike and then a voltage spike, and all of that within 12 minutes, then it's a high severity alert. So here you really talk about real-time information. So here it says within 12 minutes, and that's really a sliding window in 12 minutes. It's always in real-time processing information while it's happening. In this use case in 12 minutes, in other ones it's in 2 seconds or something like this. So for example in financial trading it's a much smaller window. There it's even sometimes just microseconds, so that's really crazy. But depending on the use case it's different types, sliding windows, but you correlate the different microservices to get the added value. And that's really what we see, what brings the most value when you implement the flexible microservice architecture, that you can then nevertheless correlate in real time the different information. And we see that in every industry. In retailing, for example, for cross-selling. Fraud detection is very important, also for retailers, for banks and so on. Predictive maintenance is important everywhere where you build something like automobile, or here like the oil platform or something like this, Internet of Things, manufacturing. So really these use cases are everywhere about correlating the different events. And though that's really, in my opinion, the most important. I have another slide deck which you can see on my blog. I had the talk at Java 1 last year, and there I'm really comparing some technologies which are implementing exactly this kind of stream and event processing. So just a short overview again, you still can again use open source framework like Apache Flink, Samza, Apache Spark Streaming, Apache Storm. You can use closed source cloud vendors. Even vendors like Amazon and Microsoft are offering such kind of stream processing frameworks. Or on the other side again, you can use a product like TIBCO Streambase or Software AG's Apama, IBM InfoSphere Streams. That are the products again. And again, the trade-off is they are much more powerful, you have much more features, you probably get much better performance, and you also get the 24/7 support for all of that and the consultants. And then you have to do the trade-off. Do you want to buy that and pay money for that, or do you want to implement it by yourself? You can implement everything with both. It's always the trade-off, what's the better one for you. And this is just one example of what we are usually building in customers, also a real-time UI on top of that. So here we are really integrating the microservices. As I said, usually when here I talk about microservices, it's about events. So it's not about REST services, but about message push. Because otherwise it doesn't make sense to correlate millions of messages. And then we build on top of that a UI. And here again we have a product which is called TIBCO Live Data Mart, where you can drag and drop all of that. If you use an open source framework or JavaScript and WebSockets, then you build by your own, would of course work the same way. So that was a lot of theory now, a lot of information. Now I want to show a short live demo also to give you a little bit about a feeling about how we, one example of we implemented some customers' microservices. Let's take a look at one architecture slide before I switch the screen. So what I will show you now is how you build different REST services and coordinate different REST services with TIBCO BusinessWorks Container Edition. Container Edition, the name says it, it's really a lightweight cloud solution which deploys it to containers. And here I will build the REST services. I could in the same way build SOAP services or integrate anything with JMS or messaging or so, but here today I will show REST services. But as you see here, again, our customers, they do not do everything with TIBCO, but they use Node.js or Java or Spring or so, also on the same platform as a service, cloud. In this case, we are using Cloud Foundry, an open source solution. And that's basically where I deploy the services. Then I can use many benefits like scalability. I can automatically scale and I don't have to care about all of that because Cloud Foundry does that for me under the hood. So that's how to build the REST services. And then I will also take a look at how to log all of, to use the log management to monitor all of that. I will show you Papertrail as a very simple cloud example how you can log the distributed microservices. And then I will show shortly TIBCO Measury, which is one of these API management solutions, which you can use to offer and expose them to others via a portal that everybody can read the documentation and try them out and subscribe to them. What I do not have today is the last part about the event processing demo, but that's also, as I said, an interesting part of it. So let's now move to the live demo. So what you see here now is TIBCO BusinessWorks Container Edition, the IDE. As you see, it's Eclipse-based, and what I just want to do is I will just implement a very simple REST service to get a simple feeling about how we do that. And here, let's say it is the resources Dublin customer, so because I have the other customer already. So I'm building a customer resource, right? And here I'm also adding a parameter ID, so that everybody, let's say in this example, we will build a get for this ID of the customer resource. And the resource definition is here a customer XSD, so it's a very simple one with 3 or 4 attributes. But that's basically the idea how the vendors do it. So we also support JSON, of course. You can have JSON interfaces and parse it, but under the hood, the engine under the hood always uses XML. And the reason for that is that only with XML and XML schema especially, you can do things like graphical mapping easily. And therefore, the vendors use it, and all vendors in the meantime I think are happy with it. So because things like performance advantages usually are no reason in the scenarios we see. So yes, it's a little bit slower and so, but therefore you have the benefits of, for example, graphical mapping and all that stuff. But nevertheless, you can also use just JSON and so on for REST service and so too. So here, let's say here they get a Dublin customer and we return a customer. So this is really a simple REST service where I do a query, a request for a customer ID, and then I return the customer object in the end, or the information of the customer. So to keep it simple here. And so now it generates the REST service here. By the way, also if you build a SOAP web service or any other integration process with JMS or something, it always looks the same. You just build this thing here in the middle, and the interface on the outside is here on the outer thing generated. And what you typically now do, if this is a request for a customer, then you, for example, get it from a database or from somewhere else, the information. In this case, I will just use a log activity here to do something, but usually I would here, for example, use a JDBC activity and query a database to get the customer information for the ID which I get here. But to be honest, I have not installed a database here on the Mac right now. But the basic concepts are always the same, so that doesn't matter. No matter if you integrate with SAP or JDBC or JMS, you always use the same ways. You just do the graphical mapping, and that's really, and I really want to highlight that again, that compared to 10 years ago that changed. In the meantime, this really works very well, even for very complex scenarios. At least at TIBCO, but I think also at some other vendors. And so here, as you see now, on the left side here, I have the input, which is coming from the GET request. And in this case, I just get the ID because I just have one parameter. And so let's write something here in the log file. Therefore, I will use a function first, a concat function, and to say here first request by customer, and now the second string here is the ID. So here I go back to the ID and drag and drop it here. You see it here in red. So now it maps here and return. And this is my log. But in the same way, as I said, the graphical mapping and so on is always the same, no matter what you want to do. So here I have the output for my REST response. And here you see, here it's in the end the schema of the customer. This is the resource, the customer schema, which I have defined here somewhere. Not here, but the schemas. the customer XSD. And so, again, let's keep it simple here. So here just the ID, and usually I would implement the other ones. For example, I would get all the other data from a JDBC connection or from a NoSQL database or wherever it is stored, or do another REST request or SOAP request, doesn't matter. So, and let's say here, mock, and 1, 2, 3, and dummy. So now it's almost done. Here's still an error, and that's also so the tools are really sophisticated in the meantime. So you can do, for example, here now it complains that the ID is an integer here, but I'm getting a string, and so let me just click here on the show check and repair and quick fix it. So then it automatically adds the conversion here, and now hopefully it should work. And let's now test the service here. I will go to the debug mode and start this application. So in the meantime also, it's not like 5 years or 10 years ago where you really had to deploy to an external runtime or something like this. So here you now really just start it. As you see, it's just Eclipse like you write Java code. So here you could also integrate Java code and debug all even together. So you could also use the Java perspective and write Java code and combine it together and debug it in one step. That's also possible. And now in the background it's running an embedded runtime, which is, by the way, also based on OSGI. And hopefully I did not do an error, and so I did. It's always the same for live demos. With mesh model, okay, then fortunately I've prepared a working demo, so it looks the same. That's always the problem of live demos. So I've tried it in the hotel an hour ago and that worked. So let's take a look at the load balancer demo, because this is also the one I have deployed to Cloud Foundry then. It's in the end the same. As you see, it has another logging because I'm logging the host and the port. And now let's run this one. So, load balancer. And let's hope that this one is running now. And when it is started, then I can, as I said, by default we use Swagger as interface language for REST services. Swagger is an open source framework used by many vendors like JBoss and Talent and many others. And we also use that in our different products. And so let's see, started by Visual Studio, looks better. Yes, now let's find out the REST doc, the URL where it's deployed. And now in the browser, we see here's the Swagger interface. So here I can easily now test this REST interface. And here I have just to enter my customer ID 555, and then here it's returning the information that is implemented for me. So now this is a very simple service. As I told you, of course the most integration services are much more complex with many other technologies integrated like SAP and Hadoop and whatever. The implementation is always the same with the graphical mappings. Of course, for JDBC you have other connection data, and for JMS you have queues and other concepts, but the graphical mappings and transformations and all of that is always the same thing. And you can also, and that's also important here, for example, let's go back to the to the other one, Microservices. So now, for example, you could also here, if you want to orchestrate different services. So if you have 10 microservices, but you have to orchestrate them, then you might build one REST service or SOAP service or whatever which orchestrates them, and then you can just drag and drop other services in here, and then combine them here, right? Here, double click, I go back to the other one, and this way you combine and correlate them. And all of them have the input and output, which you can use for graphical mappings. And that's the way you implement all of that. SOAP, REST services, JMS, and any integration technology. So always this concept here which you use. And then the next step now is deployment. So let's say we have our microservices. Then you can deploy them. You can use an on-premise engine which you scale by yourself. In this case, I use Cloud Foundry. So Cloud Foundry, as I said, is an open source platform as a service where you do not have to care about scalability and so on, because the provider does that for you. But it offers a lot of additional features, and here, let's see if I'm logged in. So, okay, so I have different services, and I have already deployed exactly this service which you have just seen, the load balancer demo service. And now here you see the service is running on 4 nodes right now. And so you do not have to care about scalability. So let's say we want to scale this up to 6. You could do this manually, but in the real world, of course, this is scaled by scripts automatically. So if the load is at a peak level, you simply scale it to more different engines. And the same way, you close it down again. And the platform as a service, in this case Cloud Foundry, takes care of that, and you don't care about that. You just implement your microservice, deploy it here, and the scalability and so on is here out of the box for you. And also, this is now specific to Cloud Foundry. For others, it works a little bit different maybe. But in this case, you bind other services. And now what I did here, I bound the paper trail log management solution. So again, the log management is really to analyze the different information of different distributed microservices. And in this case, I have connected paper trail, let's see, paper trail here to my Businessverse Container Edition demo. And here now you see, if I click on it, that it's now showing all the logs of the different microservices. So all these log management tools are the same, no matter if you use a framework like Logstash, or a software as a service like Papertrail, or an enterprise solution like LogLogic or Splunk. You integrate all the distributed logs of the distributed microservices. And by the way, a log is not always a log file, but could also be a message or an event or something like this. And then you get all this information together. And then with a simple solution like this one, you can do basic searches. So for this one, it's sufficient. So let's do one more call here. This is a REST service, right, which I deployed. So let's do 1 or 2 more curl REST requests here. This one, and you see here the different logs. You already see them here in Papertrail also coming. And now let's search, for example, for customer 123. And here, before I search for it, it's important here, I log the host name. And the host name is a different one because Cloud Foundry is running on different instances, right? I scaled it from 4 to 6. So right now it's running on 6 different instances, and each one has a different host name. So it's really a distributed system. And with these log analytics tools, you can now search for this customer 123, for example, and then you see all the different logs where this comes in, no matter on which distributed node this runs. And that's the way how we get the microservices back, to get all the information back together to analyze it, to create alerts or do more correlation on top of that. And here then is the difference that these basic software as a service vendors, they're not really powerful. Here you can do some basic searches, and you can also then create alerts. For some use cases that's absolutely sufficient. But if you want to do really more complex analysis with correlation IDs and then find the root cause, for example, then you will probably need a more powerful tool like Splunk or something like this. Or again, you could do run, of course. So that's the log management part, where the distributed microservices are again then monitored together. And the third part which I wanted to show is the API management part, because when you have all these microservices, then you want to expose them to others. And with an API management solution, that's very easy. In our case, of course, I show again Measure, our product, but as I've shown before, there are a lot of others on the market, open source and also from other vendors, of course. And here now you see the portal. This is where the end user takes a look at APIs. Let's take first a look at where I defined it from a service provider perspective. So I simply said exactly for this customer API, here we have it, and here's my customer API with this service. And this is again a very simple mapping. I just as you see here in the configuration, I just, in the end, it's just a proxy here, right? So I'm mapping it one-to-one, but usually in the customer scenarios it's more complex with more mappings and different rules and other security mappings and all that stuff, and throttling and so on and caching, but here it's really just a proxy in the end to show a simple example. And here I defined, again, it's just a REST service with a GET method, and you configure some more things. You can define things like error handling, load balancing if you want to do something specific and all that stuff. And after you have defined the API, then you build a package with that. And a package, like this one, contains different plans. And here I have created two plans, a basic plan and a premium plan. And that's the way that you differentiate, for example, 5,000 service calls per hour for $5 and then 10,000 for $10, something like this. That's the different plans. And so this way you expose the microservices, and then the end user, let me just log in again, and here you see the end user, and he can then use and test these services. For example, let's go here simply, make a call, and now I look at my customer API, and here you see now, here I see the different operations. In this case it's only one, and only the GET method, but here I can now try it out. And so here it's calling it again, and here you see the result. And after you like the API, you can subscribe to it. Sometimes they are for free, sometimes you have to pay for it, and then you can use these APIs by yourself. Let me just show you, for the finishing the demo, two more examples of hopefully I find it, of customers, how they are using it. Marshall, is there somewhere? I forgot what is the. Was it's very nice examples. One more second, if I find it. Okay, okay, here it is, I think. Yes. Let's take a look at Sabre. Okay, whatever. But I also think this is not. This is just the pictures. This is not a link to it. At least not to the ones I want.
Left-hand side.
On the left?
Yeah, you could have done.
Here it is. Okay, let's take a look if that works. Because now what I wanted to go is read to the API, but now this is just a customer success story. But somewhere you find all the APIs, and there it's the same way like here, what I showed you. But here you can take a look at the customer APIs, because their goal is really to expose the microservice to the public. And for example, with Sabre is an airline ticketing system in the US. It's similar to Amadeus in Germany. And they're exposing all the APIs for flight transactions. And for example, because they have the information about prices of all the different airlines, because Sabre is the leader in the US and Amadeus in Europe. They are really controlling 90% of the market. And now they have knowledge about all the tickets, about the bookings, about the prices. And they, for example, now offer an open API where you can compare the cheapest prices, right, and find out the cheapest flights. And websites like Flüge.de and these ones, and Expedia, they use these APIs and pay for that to build their own service again on top of that. And that's the basic idea, how you combine different APIs, expose them, someone else builds a product on top of that, and then he exposes it again to others. So for example, Expedia uses this information to know which are the cheapest flights, and then Expedia again makes 80% of its revenue by APIs, because Expedia is again integrated into many other applications, like Trivago, for example, right? And that's the way how this works. With microservice, expose them and use them again. That's the basic idea behind it. And on the measuring side somewhere, you can find a lot of different examples where we can really take a detailed look at that. Okay, so I'm almost done. Okay, just to finalize this, now I told you a lot of great things about microservices. I think it's clear that it's not for free, so maybe do that a little bit faster. So the key here really is microservices, a lot of effort, and I really recommend this article here, Microservices Not a Free Lunch, and that explains in details how complex it is. And so the final statement of that article is, when considering microservices like architectures, it's really important to not be attracted to the hype on this one, as the challenges and costs are as real as the benefits. And that's the same, that's true for frameworks, open source, and also for products like TIBCO. You always have to think about, is the value worth it, and think about what you're doing. But in the end, I think in the future we will see a lot of more microservices. And one reason for that is that the products and frameworks are getting much more mature with that and offer a lot out of the box. And so I'm sure we will see a lot more of that with customers. And we see that especially, as I said, the customers come to us and ask us how can we implement microservices with you, and not the other way around. So to summarize again, what from my opinion I told you today is microservices so done right, how I explained it today. From our perspective, from an ESB, services are developed by itself, scaled independently and deployed by each other, and not a central ESB broker. And integration is the key for success. As you see, you have to integrate everything, SAP, mainframe, but also external cloud services, APIs, and so on. All these use cases where you have to communicate a lot more with partners than in the past, like with Internet of Things, or like the Sacramento Kings Stadium, where you work together with restaurants, with sponsors, and so on. And then the real benefit is really, and that's really where the companies will make more money out of in the next years, is the event correlation of the different microservices. Because that's really what many companies do not have yet, and that's what's coming next 5 years at every enterprise, I'm pretty sure. Okay, so that was a long talk, a lot of information. You hear me, I cannot speak much more, but I'm done, and I think now we can go to questions on it. So, any questions? Or again, I have no problem with other opinions. That's absolutely okay.
So do you see ESB as a key to the correlation? Like, is it?
The question is, do you see an ESB as a requirement for the correlation and so on? And the answer is not an ESB, but you can only do the correlation if you have integrated the system somehow. So either with an ESB or with an integration framework or just with a REST approach. But if you have not integrated the information, you cannot correlate it. So that's also why most of our customers are just starting doing it, because before you haven't done all the integration successfully, you cannot correlate it. So that one is always integration, and then you do event processing and analytics on top of that.
So on your CEP system, so you have your events coming in. How do you determine that correlation rules? Do you have any supporting tools for that, or is that, that's the hard question, obviously?
The question is, what was how do you get the information from SAP systems and so on?
No, see, your event processing. So your CEP's complex event processing system.
And the question is, how do we get the insights? Or
yeah.
Yeah, okay. So that's two parts in the end. So that was not the main part of this talk. But of course, you need to get these insights somehow. And the way that works is usually that first you take a look at historical data and analyze that data. The data is usually stored in Hadoop or some other big data stores or something like this. And then you use data discovery tools like Spotfire or Tableau or ClickTag and so on to analyze the historical data. Sometimes also, or even more in the meantime, data scientists are coming also with R and MATLABs and SAS to do machine learning and find out patterns of the historical data, of the terabytes and petabytes. And then you get a short formula, and this formula you bring into the real-time processing in action. So that's the way it works. And for example, with TIBCO, what we do, there really the data scientists can develop an R script, for example, and build a model based on the historical data. And without any recoding, we can put this model into real-time processing. And one example for fraud detection is that if you take a look at terabytes of data, historical data, and you find out what might be a fraud, and then you have this algorithm, an R model, and then you really use this R model with every new transaction. So for example, at Walmart in the US, they had this problem with gift cards. And again, like many of these customers, they had batch processing overnight. So only in the next day, they knew who has used which gift cards. And the issue was that some guys were very smart and they used one gift card and went to 21 nodes and used it all the time, but it was only allowed once. But again, here they only found out after it was done the next day, and that was too late. And now they use this kind of pattern. They took a look at these patterns of the historical data to find out how these smart guys did it. And when they found it out, then they could use this model to implement it in real time. And now it is implemented each time at a Walmart. Someone is using a gift card. It is processing it in real time and using this model to analyze, might it be fraud? And if yes, then they stop, this was already used or something like this. Okay, no more questions. You can always contact me via email or so. I will not stay much longer today. As you hear, I'm feeling not very good today. That's unfortunately today, but I hope you liked the talk a lot and give me feedback afterwards and write me emails if you have questions. So thanks a lot for coming.
Thanks.